Welcome back. Thank you for doing these problems. Let's kind of go over them fairly quickly here right now. So the absolute value of x equals 5. There's two solutions here, 5 and negative 5. Again, I need the solution that is positive 5 away, and I need the solution that is negative 5 away. Number 2, I need the solution that is positive 10 away, and I need the solution that is negative 10 away. So I'm going to solve each of these to find those two solutions. So I get x equals 13, and I get x equals negative 7. And number 3, again, I need the solution that is positive 13 away, and I need the solution that is negative 13 away. So I do the same solving techniques I've always done, and I get that one of the solutions is x equals 5. And then for the other solution, I get 3x equals negative 11, and dividing by 3 on both sides, I get x equals negative 11 thirds. So my two solutions are 5 and negative 11 thirds. If you got any of those wrongs, make sure you address that with me, and we will get you help clear that out. Otherwise, let's move on and talk about absolute value inequalities. So inequalities are going to be slightly different because we're looking at a larger group of numbers. Let's take that same absolute value of x is greater than or equal to 5 this time. So we're looking for every number that has a distance away from 0 that is bigger than 5. So let's think about the number line on this one. And if this is 5 and this is negative 5, where are the areas that have a distance away from 0 that is bigger than 5? Remember, it can be anything. So here's 5, and 5 works, so I can kind of put a dot there. But then it says the distance away that's bigger than 5. Well, where's the area that is bigger than 5? That's to the right. Which means that every number from here to the right is a number that makes this a true statement. All of these numbers have a distance away from 0 bigger than 5. But there's more, right? Because negative 5 is also a distance away from 0 equal to 5. But any number smaller than negative 5 is a number that is bigger than a distance of 5 away from 0. So like negative 6 and negative 7 and negative 8, they have distances away from 0 bigger than 5. So notice how this kind of goes along with what we did in our previous lesson, right? This is an OR statement. In fact, this greater than sign, anytime you have a greater than sign, you're going to end up with an OR statement. Remember, great or than, right? I'm spelling it wrong on purpose. Whenever you have a great or than sign, you will always create an OR statement with your two inequalities. So let's do this example down here. The absolute value of 4x plus 5 is greater than 13. We're going to do the same thing where we split it up. I need the solution that is greater than 13, right? That's going to be the area over here, greater than 13. But I also need the area that is less than negative 13. Notice how when I write this second equation that I had to flip the inequality sign and change the negative sign of this. Because I'm looking for the amount that's greater than 5 or less than negative 5. For my example, I'm looking for the area that's greater than 13 or less than negative 13. Greater than makes OR statements. And then the way we solve here is exactly the same as what we had. So x dividing by 4, we get x is greater than 2. And then we do the same thing over here. We get 4x is less than negative 18. Dividing by 4 gives us x is less than negative 9/2. So there's my solution. X is greater than 2, or x is less than negative 9/2. Again, I needed to flip. I needed the one greater than 13, and I needed the side less than negative 13. So in that second inequality, I had to flip the inequality sign and the number. Let's do our last example here. What about AND statements? Well, let's look at that same example. X is less than 5, or less than or equal to. Now we're looking for all numbers that have a distance away from 0 that is less than 5. So this area over here was less or was greater than 5, but this area over here is less than 5. And in that same manner of thinking, this area from negative 5, if we're talking about having a distance away from 0 that is smaller than 5, that's this area. So this line in between are all the numbers where the distance away from 0 is less than 5. In other words, we made a compound inequality. Negative 5 is less than or equal to x is less than or equal to 5. Again, from the last lesson, remember what we did with compound inequalities. Anytime it's compound, it's an AND statement. In fact, anytime you have a less than statement, you have an AND statement, right? It's less than. Less than. Notice that I'm saying it wrong on purpose. Less than. Less than. And. Less than. So a less than symbol is less than AND statement. And what that tells you is that you need to make a compound inequality. Make a compound inequality. So let's do our example here. We have 7 minus 2r is less than 19. I need to make a compound inequality because I'm looking for something that is less than 19, right? That's the first part, less than 19. But I also need something that's greater than negative 19. So look, over here, just like we made this compound with the negative 5, we're going to do the same thing over here. That's a 7, right? So we have our initial 7 minus 2r is less than 19, same as we have here. But because it's an AND statement, we make a compound inequality. And now we solve this. We subtract 7 from all three sides, and we get negative 26 is less than negative 2r is less than 12. We divide everything by negative 2. Oh, we're dividing by a negative, so we need to remember to flip our signs. So this is 13 is greater than, r is greater than, again I'm flipping both symbols, negative 6, and the r is by itself, so we're good. Now the only thing that we need to make sure that we fix from here is to make sure that our compound inequality goes from least to greatest. So this is negative 6 is less than, r is less than 13. So notice that with absolute value inequalities, there's an OR statement and an AND statement. OR statements are greater than symbols, right? Look at the symbol. If it's greater than, it's an OR statement, greater than. Look at the symbol. If it's a less than symbol, it's an AND statement, less than. If it's an AND statement, make a compound inequality. So you make a little, as you just rewrite what this is and make a little thing over here with the negative side. Solve it. Make sure it's least to greatest. All right, I got a couple more practice questions for you on the Canvas, so go do those, and then there'll be one last video that has these two questions, the last two examples worked out for you, okay? So we'll see you in just a second.